everyone, we're going to determine whether the series is absolutely convergent, conditionally convergent, or divergent. So first let's look at the alternating series test and test for just convergence. So I'm going to let this part be my b sub n. So I'm going to let b sub n equal n divided by n squared plus 4. For this to be positive, n is going to be greater than or equal to 1. Now, we need to see if this part right here holds part 1. That means my b has to be decreasing, and we're going to start for n is greater than or equal to 2. So if I substitute in 2, I will get 2 divided by 8, plus if I substitute in 3, I'm going to get 3 divided by 13. Substitute in 4, you get 4 divided by 20. So this is decreasing. So our this is b sub n. This would be b sub n plus 1. And this number is larger than this number. So that holds. So the next thing we have to do is check condition 2. So take the limit as n approaches infinity of n divided by n squared plus 4. If you divide everything by n squared, get the limit as n approaches infinity of 1 divided by n divided by 1 plus 4 divided by n squared. This goes off to 0 because that is 0. So the limit is 0. So our series is convergent according to the alternating series test. We're looking to see if it's absolutely convergent to use the ratio test, but first let's look at the limit comparison test. So what I want to do is let a sub n equal 1 divided by n and compare it to our b sub n. And to do that, I'm going to use the limit comparison test and take the limit this way. So my a sub n is 1. So we're doing this. The limit as n approaches infinity of a sub n divided by b sub n. This is going to be when a sub n equals 1 divided by n. All right. 1 divided by n divided by n divided by n squared plus 4. All right, simplifying this, I get the limit as n approaches infinity. And this is going to be, I can multiply those two and move this up here. So that's going to be n squared plus 4 divided by n squared. Now dividing everything by n squared again. Let's see what we get. We're going to get 1 plus 4 divided by n squared divided by 1. All right, so when you apply the limit and put infinity, you're going to get 1, which is greater than 0. So that means if it's greater than 0, then either both series converge or both diverge. But this, the harmonic series, this is divergent. So that means with comparison, that means this is also divergent. Since we did the two tests and we got a convergent with the alternating series test, but divergent for this test, that means our series is conditionally convergent. And that's it. Thank you. Have a nice day. Bye-bye.